Awesome. Yeah, thank you for that introduction, Ron. Yeah, hey, you're a great salesman, so we can't say no to you. It's very hard. And no, these events are awesome and great, and hopefully we can present and create more education and knowledge about the energy sector and the ways that we all can adapt a clean, green energy economy, because this is happening. It's happening now, and it's happening fast, which is really exciting. And so, yeah, brief introduction. Yeah, my name is Corbin Davis. I'm our director of energy at OneSource Sonepar, and so part of our philosophy has been so we are essentially a one-stop shop for energy projects of how we want to structure and organize our company, but also try to help the marketplace, because as we know, as we're learning, this is a whole macro ecosystem together for everything and parts and pieces to work together to bring us the energy goals, the clean energy goals, sustainability that we're all trying to reach, and of course to combat all the negative climate impacts that unfortunately that we're seeing with all these recent events. So my thoughts and prayers are with any of you that are in Florida. I know it's a very scary time for that, and of course the power outage situation is going to unfortunately happen. It feels like, and of course we're going to talk about two different solutions when it comes to when unfortunately we have fires out here in California, when we have hurricanes or tornadoes out in Oklahoma and Houston area. And so the energy world it's a really unique, exciting place to be right now, because at the first time we have all these new technologies. We have these new technologies that are almost evolving into one market that we're all trying to transform our energy industry. And as we know, like without energy, without power, things stop. Things cease to mobilize and into advance. So right now, currently we're working on retrofitting, transitioning our whole energy economy and basically society through a national standpoint. So what that means to do that is we have to have multiple parts and pieces talk to one another. And so like as we have this graphic here, we see solar, we see wind, we see a generation plant. And so energy is a combination of multiple technologies and multiple marketplaces combining into one market, all at a head-on collision essentially. So now we have Internet of Things. Internet of Things market and technologies. So essentially, what is Internet of Things? Pretty blatant, simple. It's how can I have machines talk to one another? Internet of Things. I can have my solar, my battery. I gotta have my solar, my battery, and my wind be able to communicate with one another to ensure that we are all on the energy same page, to know what energy is being stored, what energy is being produced, and what is that city or utility going to get that energy, or my house going to get that energy. It's all an interconnection web of an ecosystem together that needs to interact with each other. So now we got energy, we got Internet of Things, but also we got money. We got energy as a service. And so now we work on large scale projects, but also more on a macro standpoint for, let's just say, campuses, communities, or just a specific building. So now there's huge energy developments that are out there that's going to be providing certain utilities, certain energy commissions, the power that it's looking for. And so how it's kind of structured and working now is people are investing into these huge these huge energy production plants, these power plants basically, from a clean green energy perspective, and then selling that to other entities. So whomever wants to take that and buy that at whatever rate. And also there's ways and means for the private sector, for essentially, let's just say my own office building, how I can capitalize and make money off of this new clean green energy. And that's what's kind of the coolest thing that's, being in this sector is, number one, we're doing a great thing. We're retrofitting our cars to become electric. We're reducing emissions. We're retrofitting the whole marketplace to be clean green energy. So usually transitions like this, it's a heavy investment, but with investing into energy, there's returns. And so that's why it's a great time to be in this market, especially with all the new efficiency and technology that is happening, where it's actually all making financial sense, all coming together. So now we have a whirlwind all coming together, where we have the financial sector, we have the energy sector, we have Internet of Things, but also cybersecurity. So now we got to secure everything, right? So unfortunately, we've had a situation. I think it was, not to mention any names. I think Russia tried to hack into part of our structure a couple of years ago. And so now we have to secure everything. So unless we have secure protocols, essentially if an entity, another nation tries to hack into our infrastructure, security is obviously a huge thing. We have to protect it and have reliable infrastructure available for us. And so We're going to blend all of these systems coming together in order for a whole economy essentially around the energy sector. And so that's where we positioned ourselves at OneSource, is to be that one-stop shop to understand what is needed for projects. So we've had a lot of opportunities where, investment bankers or developers or, CFOs for individual companies go, we have these ideas. So we want to become clean green energy. We want to become 50% sustainable. We want to offset our carbon emissions, but how do we do it? So how do we actually, what does it look like from our concepts and then take it into actual project implementation? What parts and pieces are needed? So if I have to do it individually, I have to go to a solar manufacturer, a racking manufacturer, an inverter manufacturer. Not just 3 parts of a solar system, but if we're doing a whole energy economy, we need chargers, we need batteries, we need wind. So we just restructured ourselves to be a one-stop shop for energy projects to help bring these great ideas and these great projects to the marketplace. Have a seamless and easy transition for us to hopefully achieve all together. So the quickest way, we just say there's so many ways that we can cut up sustainability. We can essentially take out our plastic straws, put paper straws in. We can, of course, retrofit our fuel resources with our vehicles that we're operating, have strategic, recycling measures at our facilities. But a lot of it is the fastest way to get to clean green energy is by our power infrastructure. So if we're able to retrofit the existing power demand and power needs to become of the clean green energy, we can almost get to our sustainability goals within a 90 to 100% immediately, just by power investment infrastructure. And so part of that too is, and I think Ron touched, briefly on, was to do that is, typically we have these projects, and then we have to, have them go through, plan checks, cities, fire codes, make sure that everything is safe to actually get these projects approved. So it's really important to understand, how we're designing these projects, and also working with a firm that we trust, that we know that we can get these projects approved in a streamlined process. I'm not an engineer or anything like that, but there's sometimes some AHJs, they're not strictly trained energy engineers. These are unique technologies, new technologies that are coming to the market. So sometimes where a new project comes, a new opportunity comes, then all of a sudden it's like, oh, I've never seen this thing before. And so if everything is not concretely provided for exactly what is needed, then we've seen in the past where those individuals will just decline it. And then that decline essentially will put the project back 4 months, 5 months. And again, as Ron mentioned, you got to start from scratch. And so that's why it's, of course, time is money. It's very important to know exactly what we're providing and that we're designing as well, because a lot of rebates and grant structures, they provide the funding based upon certain technical requirements, certain operations of certain systems. And so that's why it's, of course, so if we miss that design, we could be promising a customer $500,000 basically in funding. We miss the design, all of a sudden they're not getting $500,000. It's a huge opportunity. We've never done that before, of course, but just say it as an example. And so, recently, the president, we have a $1.2 trillion infrastructure bill. So which is awesome, is these projects they're coming and they're happening very fast. There's a lot of, it's being split up to multiple different ways. I think in the last presentation, we discussed the NEVI funding, and a lot of that's more of the initial phase to have highway infrastructure for electric vehicle charging stations. So of course, what that means is to get the NEVI funding, we have to have 4 180 kilowatt fast chargers at each corridor to connect the dots, to have the reliable fuel sources that we can travel safely around in our electric cars, but know that we'll have places to charge where we need to charge those vehicles. And so, and Ron and I have been working together over the last year. It's been great, and we've been working with some government officials, and some things that is something that that raised our antennas up internally was that there's so much money that's available, and people want to invest in these projects. There's the grants and the rebates and the funding that's trying to promote these projects, but the money is not specifically allocated for certain things currently. So just because, let's just say, if a thought could be, my company wants to do all these projects, but I don't have any means to access the grants. It's open to interpretation and application to receive these grants and these funding for these large scale projects. So I want to almost promote to the private sector of course, on a sales pitch for us, we would love to get involved and work on a project with you and try to access that funding. because it essentially is a couple of the officials and meetings that we've been on, it's almost open surveying to discuss where to put this money. Where am I going to put this large pot of money, and how am I going to allocate it correctly? Who are the people that need this type of money? So if we're able to get involved and work with you, we can essentially do a design of the project, submit that design, and of course, reserve that funding with all this money that's available for you. And so a cool little graph that I really like on the left side is showing the battery storage capacity. So I'm passionate about battery storage because I think a lot of it, in my humble opinion, and what we've seen in the market and what projects that we're really starting to really come our way is large scale battery storage. And so it's no coincidence that electric vehicles and battery storage is becoming popular currently right now. Essentially, it's so for large scale battery storage that we put at, for utilities, or just for commercial opportunities. We have a project with in Chinatown, actually a huge supermarket in downtown Los Angeles. They lose power 2 hours every single month, 2 hours during every single month, but it's variable of when that power gets shut off. But they have a lot of cold storage. When they lose 2 hours, that's huge. And of course, having that battery backup, they're able to have reliable power and power infrastructure. But also, there's so much. I mean, we actually had a presentation with the customer yesterday, and the sale price, because of the rebates and incentives, the battery storage opportunity was 75% off, just because all the rebates and the grants and the tax credit incentives that are available. So it's a really cool time right now, and we're really from a macro perspective, we're really pushing this technology. And so, same technology with large scale battery storage from a utility standpoint that would be in our electric cars, lithium-iron phosphate. Same exact chemistry. And so that's kind of why now they're all coming together. Battery storage is actually efficient now. So now we can put all these battery cells in our cars to reduce our range anxiety, essentially, so that we can have our 200 to 400 miles of range. Of course, the battery aspect, I can invest into it where it's going to be a good return. I'm not going to be paying so much money for these huge systems where I'm not going to get as much energy savings as I would like. And so, I know that in the last presentation we talked. So I live in California. I live in Huntington Beach, and so we had a crazy heat wave. Using Huntington Beach, we don't need AC, and definitely need some AC there during that time. And so we were getting power warnings. Like even if we're watching TV, like the whole TV program would stop and be, please reduce your power from this time frame. We're having a load critical situation that's happening. And this was going on for over a week. We get text messages and basically infomercials on our on the TV when we're watching TV. And so right now during a heat wave, we have so much HVAC load and demand that the grid essentially, as Min mentioned in that last presentation and showed the graphs and what was happening during that time frame. But yet we don't even have any DC fast charger infrastructure currently available in the marketplace. So we already have critical loads, and without the heavy duty charging stations. So just to kind of give an idea, we did a project with the transportation authority. They did one transportation authority for 5% of their fleets. They wanted to do it. We did a pilot with them to retrofit them to become electric. So once we did that, so that's 10 150 kilowatt charging stations. Okay, that's this one transportation for 10% of their fleet. So now once all of them are being charged at once, that's 10 times 150, 1.5. Yes, I'm a mathematician, by the way. That's 1.5 megawatts of power demand right away that utility has to bring. 1.5 for one location. And yet the grid, we're having trouble just based upon HVAC demands. And so the point of my story is we probably have 2%, 5% of available fast charging infrastructure available to help mass adoption for vehicle electrification. So in my opinion, answers, battery storage. And because of that is we have large scale battery storage. It's basically a way that you can control power. And so now if I have these large, these fast chargers, these high power demand assets, I now have bankable power that I can rely on with battery storage. From a utility standpoint, I can have that where it's going to be, we have a huge load from 4 to 9, but thank God I have 100 megawatt hours worth of battery storage just sitting there ready to basically offset me to reduce any rolling blackouts. And for gas stations too. So again, one gas station, let's say for our gas cars, there's like 10 to 12 nozzles, I think, per each station. So again, a 150 kilowatt fast charger will get us up and running from like 1 to 10 minutes, basically. of charge. It'll take 1 to 10 minutes to charge our cars with a 150 kilowatt fast charger. So if we multiply that by 10, so that's 1.5 megawatts for each gas station, that's a lot of juice. It's a lot of power. And so we're going to have, do a lot of different metrics from a macro perspective to have that reliable power infrastructure that we need. And so a lot of what we're talking about, I covered a lot of things right there. That's a little, cool little conversation. We're just talk about, who are we, and also, discuss, how can we essentially work together optimally? What is a microgrid? And then I'm also going to dive into, what does a mock energy project look like? So if I have a building, I have these goals. Now, what does it look like for me to implement? How do we make this happen? And then if we got some extra time to dive into a little bit nitty gritty of what the products actually look like from that standpoint. And so, so we've created a state-of-the-art energy department. So it's a one-stop shop for essentially energy materials for energy projects, software, hardware, financing, engineering, whatever is needed. And so that's kind of where we're unique, is that we've already set up and structured where we have all the relationships. And so as a part of Sonopar, we're the largest distributor in the world. We have relationships with the best manufacturers for around 50 years and been fostering those relationships. So we know exactly what part and piece to add for a specific project. As we know, this building over here uses energy different than the building across the street. So every building is a customized project. And that's where it's important. That's where we like to get involved. And here's a little article that I did. And I just kind of cool that we're being recognized for the work that we're doing. And talking about these, doing the full scope for these energy projects. And just so Ron mentioned as well, we are, part of, Sonopar, we're nationwide of local hub and spokes throughout the entire country, but we can do projects all over the world. We have a couple right now in, Caribbean, and also South America, to name a few. So there's no restrictions there. And of course, here in Los Angeles, we have large scale distribution centers here in Orange County, actually Fullerton, actually, if you're from the area. So past projects we've done, it ranges from almost like all the different verticals to say. We did industrial manufacturing. So let's say that I have manufacturing loads, like a pharmaceutical company we did out in Jersey, where they have critical batches. And so if any power disruption is happening during a critical batch, that whole batch is ruined. And that results in hundreds of thousands of dollars of lost cost. So if I can bank on a solar and a battery system, I have that power infrastructure readily available. No matter what, I'm going to be covered. So for one batch, 100 grand for the investment of a battery and solar, it's pretty lucrative. And we've done a couple of largest fast charging projects in the country, which is pretty cool. We had a city just go, hey, I want to be known as a city with the most fast chargers available in my metro area as well. We're like, sure, yeah, let's do it. We'll put together a solution. We did over 50. This is a couple of years ago. 50 kilowatt fast chargers for them. A lot of experiences with fleets, and a lot of universities, at least in the University of California university system. We're doing a lot of investments of retrofitting the school vehicles to become electric rather than to use gasoline. And so wineries. I like this project. It's kind of a cool story. Anyone that likes Cabernets, Paso Robles Cabernets by chance? So unfortunately, we deal with a lot of fires out here in California. Central Northern California is very prone to fire hazard. So Paso Robles is unfortunate area, but it's also great Cabernet wine country out there. So we had a customer come to us and say, hey, I need a reliable power infrastructure for fermenting my wine. Because now the California Public Utility Commission, if there's any fire endangerment that's currently going on, they can shut off the power. They can turn off the power immediately. And so that leaves firms and companies just all of a sudden without power because of fire hazard. Of course, that's great for fires, but we're talking about businesses and we have critical batches like our beautiful Cabernets. That's tough, really tough. And so we designed a solar and battery system. So it was a microgrid basically. So they have a reliable, clean, green energy power structure to ferment those beautiful Cabernets. So sorry, next time you have Paso Robles Cabernets, unfortunately, maybe you'll be thinking about me. So yeah, sorry ahead of time for that. So all the different parts and pieces that we do, solar, HVAC, EV charging, turnkey solutions, rebate consulting and management, engineering, microgrids, carports. We have money systems, a lot of financial instruments that are pretty unique and cool. So if customers don't necessarily want to put the upfront capital for the project, we have many different financial partners that can do creative strategies to ensure that our goal is always to do cash flow positive investments. customers own the assets, and of course, we'll try to make sure those energy savings are going to be greater than the payments every year. But also, the customers will always get rebates, grants, and incentives as well. So the cash flow statements look pretty dang good when we do a finance project. So one of the things that we do from a building perspective, we'll do a full scale design build basically. So right here, we'll do a full layout and of course bring it up to code. So certain jurisdictions, and Ron said, like AHJs, have different codes where it's like this one right here, you have to have 4 feet away from the roof for your solar system. You have to have a clear path away from HVAC maintenance and assets basically. So if anything goes wrong, of course, we have to have a pathway to get to these assets on the rooftop. So it's very important to, of course, to do that work up front and to get that project approved that way. Because again, if the city goes, no, it's not going to work. That's you missed that. Again, we're behind by months, and that's the last thing that we want to do to incorporate. Ron, how much time do I have left, by the way?
Oh, we got a good 20 minutes or so. We're fine. We're
beautiful. Awesome.
Okay.
Okay, and then so what we do a lot, so it's what we'll provide. We'll do a little design build. So it's very like if we have energy goals from a building perspective and a company perspective. So how do we do it? So what is the step-by-step process almost looks like from that? So there's 2 different parts in the design process. So of course, I need to know your energy. We need to know your energy demand, right? So what is that energy demand? So how much energy am I using? So of course, once I know that how much energy is being consumed, how much energy do I need? Now I can do a product design to make sure I can provide you a reliable power infrastructure. But of course, but then what is our goals? Is our goals as much energy offset as possible to become 100% sustainability? Or maybe does my CEO want me to be 50% sustainable? So now, of course, knowing these type of things, we can do the designs appropriately, either to increase the investment, to get the fastest return on investment as possible, or to reach our sustainability goals. And of course, the last one would be, I would like to do a microgrid. And that's where it's like, I want to be independent. I don't want to draw any power from the utility. And of course, it's a whole different design. There's definitely a return on investment, but it's not as fast as the other ones. Because of course, the reliable power structure, independent from the grid, has a lot more power asset. A lot more power assets is needed just for security measures as well. So a lot what we do too is consulting and design. We work with a customer where it's like, hey, I need to provide power for a subdivision, for a community. So I need to have, so how much power, so here's our power goals, or here is the energy profile of this community. Now, can you please help design a system to be able to provide that correct amount of power for my subdivision? And so that's where we can get up front and do specific product recommendations. So what is the best manufacturing product that you need? What is the size that you need to have that reliable infrastructure? What does that footprint look like? So all the different necessities. So it's like, I want to start doing these ideas before I actually want to go to bid, or before I want to get the budgeting associated for a large project like this. So we can help on the consulting side to get the framework, the sizes designed and inspected in, to create an accurate investment of what this is going to look like. And of course, the investment, but also most importantly, provide the reliable power infrastructure we need for the application essentially. And of course, for fleet design, we do a lot of, so of course, it's very important to know, sometimes there's a common theme, it's getting better that we've seen, is people will try to spec in certain fast chargers for vehicles. So what's part of the equation too is we have to know what kind of battery is inside of that vehicle. Because sometimes vehicles will have like current limiters, or so like current limiters or certain specifications inside of that vehicle where they'll only take a certain amount of power. So let's say we invested a 150 kilowatt fast charger, which is going to be around 100 to 125, 150 grand. But the car can only take 50 kilowatts worth of charge. And that was going to be cost around 40 grand. So now we have this huge investment of power infrastructure and charging costs, but the vehicles of concern can't even take that high load. So now we just essentially way overly priced our systems. And so we can provide all of that work for our customers, but also too, it's pretty cool where we can do calculations to go, okay, Mr. Transportation Authority. So if we use this charging station with that bus, we can get that bus out full charge in 2 hours and 56 minutes. We can get it down to like a 6-minute ratio to get them in and out. 6 minutes. 5 is a little harder, but yes, 6 is pretty good. But the part of this slide is, if we have land, we can be creative and put, we can find energy places to provide energy production. Now, sometimes where it's like, hey, I got a building, a small roof space where it's all, it's a lot of HVAC equipment, so it's hard for me to put a solar system. That's okay. We can just increase the racking size. We can just make it taller. It's a little more structural engineering on our part, but that's totally fine. Or carports for large scale parking lots. We have parking lots, so it just wasted space out there. So now if we can take that space and turn it to a revenue producer, now we have another revenue stream based on space that wasn't producing any revenue before. And also we're providing clean green energy for our customers and for the applications. Here's a couple of cool past projects on this slide that we've done. The one on the left, I mentioned that before, was the largest fast charging project in the country for one of our cities. And yeah, we have one that's pretty unique, where so this is a utility wanted to have a portion of their subdivision become a microgrid. So it was for the southwest sector of the utility's jurisdiction. Like, hey, let's try this out. Let's do a couple of battery design for reliable backup power for what we need, but also let's do load shedding strategies and also provide the solar mechanisms needed to do that. And so, of course, we're unique on the battery side of things. I don't want to get too nerdy with how specifications on batteries, but we're modular designed for the battery, so we can do multiple different strategies inside of one battery container to reduce the investment for battery storage apparatuses. All right, so a microgrid. Try to get more of an idea of what a microgrid is. So I've kind of broken it down to, we'll try to have a simple explanation. To have a grid in a centralized controlled location. Currently, right now, we have power plants outside with our in our local utilities and power producing entities. So now with a microgrid, I can have my own reliable power infrastructure anywhere I want, and I can make a lot of money doing it too. I can get a fast return on investment by doing this as well. So now it's before having to rely on a power infrastructure that's available from a utility or from the municipality, but now I can have it my own. My company can have it my own power structure. And so there's two forms of it. There's a grid tied, which means you're still connected to the grid. So this is this is almost like an economic web, basically. We talked about the Internet of Things. We talked about security. We talked about the economics behind how lucrative these investments are. So a grid tied mainly is saying, okay, what is the cheapest form of power for a certain asset? Is it the utility? How's the utility rates? How is the wind producing? Do I have a lot of power available with the wind? Solar, is a solar going strong? Now I have energy stored in my battery. Now what's the best form of power that I need to use? And so essentially, once we find out those cost metrics with the software that we provide, that will tell which asset circuit to close that electrical circuit and now run power to the application to have the cheapest form of power for for us to get that return on investment. Or if we just don't want to have any relation to the utility whatsoever, we call that islandable. We island ourselves away from the utility. Now it's a more complicated design because we don't have that safety net. We don't have the safety net of a utility, basically. And so now this is a system that is completely independent from the grid. That's more of an islandable microgrid. So the values, of course, I mentioned is that you get a ROI from it. I know I have power infrastructure. I know it. So I have it right here at my facility. I don't need to worry about it. But also, too, we're becoming sustainable. We're enhancing our brand image. We're helping save the environment. There's a lot of good positive aspects that come from it. And so, of course, during natural disasters, and this was very interesting. Ron and I, we had a meeting, and we had a meeting with an insurance company. And this is something that we never even thought about. So now currently, a lot of insurers aren't basically backing CEOs if they're not investing into sustainability. We're like, oh, whoa, that's really interesting. And so the logic behind it is, if a CEO isn't forward thinking, but as kind of getting the way, following the way where the wind is blowing, but also not being conscientious of the environment and what we're trying to do is from a world economy, what other things are they missing? So if they're not even doing that, there's got to be some other red flags available. So they're hard to get company and corporate insurance based upon that. And I thought that was just fascinating. We never thought about that before. So anyways, point of my story though, for reliable power infrastructure, disaster relief insurance. So unfortunately, we do have a hurricane situation happening in the Florida territory. And so I guess, there's no benefits to that. But for a solution based upon the power outages, if we have microgrids, we have a solar, we have a battery infrastructure, we have power. So I know when a situation happens where a hurricane comes or a flood out in Houston or Louisiana, if we're able to gather power from the sun, we have power. And if I am able to get power from the sun and I have a battery system that's also attached to that solar panel, I can use power whenever I want now, if the sun's shining or not. So the solar and battery aspect is huge for reliability in unfortunate areas where natural disasters are prone. Of course, in California, for fire hazards, as we mentioned, the utilities can shut off their power whenever they want. So again, that gives us that sense of energy reliability. I don't have to worry about anything that any of my power concerns. So a lot of the solutions, man, I mean, to make it pretty clean and dry, simplicity, the main solutions are solar, wind, battery storage, and the worst case scenario, generators. So if we have to have like any like very, very, if we want to be overly protective, a generator is worth it. So like that's the main assets behind it. Of course, with many different interoperabilities with softwares and communication devices, and of course, designs and specifications within that. But pretty cut and dry. This is kind of like our sweet spot here. Here's a cool example that we did for a project. Just kind of want to show a visual for y'all. We have the light blue is, that's our solar production. So now we have the dark blue behind that. That was the current demand. And so we oversized the solar system to be able to charge the battery system. And so now the gold is showing the battery is releasing during the 4 to 9 time frame for when the power is, this customer had 2.5, 3 times more expensive power during that time frame. And so now the white is basically the new load after this energy project, but substantial differences. We talked about financing in a way. So I'll just kind of say in general, where, if there's anything that we need to finance, there's a huge pot of money available that we have access to. Working with BlackRock, there is we have access to over, at least currently, $600 million worth of funding for an energy project. So if we're able to classify a project as an energy project, we're able to access that funding. So please, if you have any interest, we can talk more nitty gritty offline if we want to discuss more financing opportunities. That's where, for us, it's very important to work with a company that can be relied upon. We've been around for over 70 years. And there's a lot of energy companies that are out there that are just now starting and kind of fly by night in ways. And so all of a sudden we do this huge project with a not as reliable company, but we're only going on okay, what's the cheapest option available? As we know in business, there's always things that are unforeseen that kind of happen in the future where maintenance needs to be done or anything like that. So working with a trusted company that's going to be around for it, that's equitable, qualifiable, and it has that long standing is important for our project 5 years from now to make sure I'm going to get that customer service and support for when something needs some maintenance. Okay, so I'm going to do a quick little example, a little run through of what does the project look like from a building perspective, but more of like a step-by-step process on this part. Okay, so first of all right, our company, we need to have sustainability goals. We want to become sustainable. Now, how does this look? So first of all, I need to gather the data. So now we need to know the electrical information. So the only way for us to do that first on the power standpoint, what is your current power? How much power do you need in order to give you that design? And so we've seen a lot of times where we'll get sustainability representatives for companies just give us kWh metrics. This is how much power we're using. kWh is a measurement of time, basically. It's time of energy. Energy is mainly a measurement of time. And so we need power. And so what is needed is kW, which is the power output. And so then also the kWh is how much of that power are you using during a period of time. And of course, when are you using this amount of energy? Because with utilities, certain time frames, you get charged a lot more or a lot less on when you're using the power. So now that goes into accordance with our designs of what our goals are. So of course, now we got to create that concept. Once we have that energy information, what are our goals? Do we want a microgrid? Do we want to become 100%, do we want to be as sustainable as possible? Do you want to achieve the fastest ROI that we can get? It's a strictly investment play. I want to make as much money as I can investing into energy. Okay, if that's the case, let's do that. Let's do a design that's going to give you the fastest payback. So now I need to know what your highest prices are during a specific amount of time, during the day, and make sure I design a system to target that time frame in order to get you that fast ROI. So now you need to design it. I create the design. I showed a little picture before of what that looks like. Do a little design for it. Okay, now I have our design. Now I need to submit it. Here's part of the plan check process ahead of time. Now I got to submit that design. If it's a battery too, make sure the battery is correctly. So again, if that battery goes indoor, I have a lot of building codes I have to work with and make sure that we're on par to get this project approved. So I have to submit our designs, essentially get that approved. Once we have those designs approved, now it's time to engineer. Now it's time to get all the electrical information down to a T to ensure that we're going to have everything covered that we're trying to accomplish. Now we have that, we get approved. Now it's time to do it. It's time to do the project. Now it's time for us, what we like to do is we try to make sure that we do controlled procurement from multiple different assets to ensure the laborers basically that they know exactly when this product is coming and during phases of certain install processes to reduce the time it takes for these type of projects. As we know in the construction world, a lot of it is, time, a lot of it is money. And then after the project is done, now our work starts to get the money for the customer. So now we essentially have to go to different rebate and grant entities to ensure that we get the funding for you and for our customers, basically. And of course, 5 years from now, we're still going to be here to help and have dedicated account managers for each project to make sure that we have the proper support that's dedicated for these type of projects. As I mentioned, this is kind of the energy information that we need broken out to how much power is being used, how much energy is being used, and when that is being used. Now we have something to work with to start creating our designs. Of course, I mentioned before, it's like grants and rebates. So they sound great. They're amazing, but they have qualifications on certain time frames with certain grants and processes that have to be met on specific intervals of time for us to be able to achieve that. We have to have certain sizes to get the maximum amount of rebates. Because some rebates, let's say a battery storage, a program for battery storage. If I do a 4-hour discharge, I get 50% rebate. If I do a 2-hour discharge, I get 100% rebate. So knowing these is critically important to know to reduce our investment costs. Of course, then we show what it looks like on a detailed economic proposal to our CFOs. What is our main metrics that we have as a company? What goals do we need to hit? And how can I show those metrics to you in a way that makes it lucrative for this type of project? So of course, this is a pretty cool. This is a roofing, solar, and battery project in San Diego. $3.2 million up front for a office campus. And after rebates and incentives, it went down to 1.8 million. So many different rebates and incentives that are available for it. I'm just kind of show different designs based upon. A lot of customers want to use. There's a misconception. I want to use the biggest, largest solar panel, the highest wide solar panel that's out there. If we do that, that means it's a bigger footprint module. So sometimes using the biggest one isn't also the best and most efficient for each project. But again, depends what our project type is. So carport design implementation, we're going to also support with this, show the detailed layout, what that carport is going to look like. Also do it by on the ground mount system as well. So there's not really anything that can limit us on a solar side. Here's some kind of pictures I want to show real quick about battery storage. I know my time is coming up here. So there's many different applications for batteries depending on what the application is. So batteries can smooth our power demand with PV. Of course, the weather patterns are different in a day, and batteries can essentially smooth that out for us. Can also provide that backup power that we need, or for demand management, given that circumstance that we talked about in California, where we have critical loads. Things are happening. Excuse me, sorry, there's a car driving by. All right. We have critical loads happening, so we need some relief for the grid. So we need to use that battery power for the utility, basically. So this is what it looks like. So we go inside, we open up that battery container, we open it up, and it looks like this. So that's the cabinets down below are the battery cells themselves. So imagine, it's a bunch of cabinets all stacked together inside of that big old container. We have HVAC system. We need to cool it down. We need to have controls and commissions for the battery to know when to store, when to release. You gotta have an inverter, of course, that transfer from DC to DC from a large utility standpoint, or from a campus standpoint, I need DC power to AC power, because we consume AC power in our society. So we have to make sure that solar production is based. So we gather solar from DC power, and we have to convert it to usable power in our communities, which is AC power. So an inverter helps with those type of that type of project. So full turnkey aspect that we do for battery storage, software, hardware. Talked about the chemistry of the battery storage. So these the same chemistry involved with our electric vehicles as it is for battery storage systems. Of course, one of the most important things about lithium-iron phosphate chemistry is it's safe. And so a lot of it is, if there's any type of, let's just say, critical circumstance that's applying, let's say pressure to that, a fire or a car crash, the battery is de-energized and dispersed. So that's part of how it works from a safety standpoint, which of course is the most important. It's highly powerful and it lasts long. It's also cost effective. So that's kind of where we're at with the battery technology and why we're getting a lot more mass deployment. I'm going to skip through this one. So kind of just to show like what this looks like from how battery systems work. We have to have, so it's all Internet of Things. We need to have a smart meter at the panel. So essentially at the main service, so electrical service for the application, I need to measure what is being demanded and what is needed. And that needs to transmit to the energy management system of the battery. They need to communicate with one another. So the utility goes, hey, I need power right now. We're getting critically low. That meter is going to tell the battery, the EMS system, that, okay, we're running out of power. We need power now. It's going to tell the battery to release its power to the utility. We went over this, the fleet design aspect. Real quick to run through. I know I'm running out of time here. Let's do a quick run through of what the charging stations look like. This is more of like a simple level 2 station. These are 4 to 6 hour charge time frame. Price point around, let's say, $3,000. This charging station's got a screen and allows to communicate with software so customers can make revenue off of the electricity, also display what's going on with the charging system setup. This is also 4 to 6 hours, around 4 to 5, around 5 to 6 grand for the charging station themselves. This is a charge point model where they try to do software and hardware all together, but they charge a premium price. There's also solutions where you can get much significant cost savings, but they're around 8,000, 9,000 a unit, 4 to 6 hour charge time frame. This one right here is a 50 kilowatt fast charger. And that looks like that's going to be around a 40 grand charger. And that's going to charge our car from 30 minutes to 1 hour. 180 kilowatts. Essentially, it's the first time on the market where there's going to be duals. So 2 cars can hook up to 1 charging station. So it's going to split the power immediately by 2 for that. But now for the NEVI funding, they want 180 kilowatt fast chargers. And so for the 180 kilowatt fast chargers, they can't have duals. They have to have 180 kilowatts of charge. And that's going to charge our cars within a 10-minute, 5 to 15 minute charge time frame. Here's what the bus charging stations look like. One is pretty cool. The one in the middle where metal comes down, connects to the bus. The driver just basically sits in the car, sits in the bus, and a thing comes down to the bus and starts charging it. Gives it 450 kilowatts worth of juice immediately, which is a pretty cool situation. Ron, I know I'm running out of time, so I think. And of course, with EV chargers, we need software available to us with the charging stations to show on a dashboard and do our energy management strategies. But Ron, I think it's a really good place to end right there. Thank you for letting me go a little over, and sorry to the group there.